Hello, and welcome to this instruction video on PyRadiomics, an open source toolbox for radiomic feature extraction. We'll start with a short introduction, followed by the PyRadiomics workflow and architecture. We will finish with some instructions for installation and the usage examples. Medical imaging is considered as one of the top innovations that has significantly transformed clinical cancer care. More recent developments have pushed towards the generation and mining of high-dimensional patient data, or big data. Additionally, there is increasing evidence suggesting the vital impact of intra- and intertumor heterogeneity on cancer treatment response. Radiomics aims to capture this heterogeneity through the quantification of the tumor phenotype using high-throughput mathematical algorithms applied to medical imaging data. These algorithms are either defined using engineered features, requiring expert domain knowledge, or on deep learning methods, which can learn the feature representations automatically from the data. It has been shown that these features can be correlated to the clinical outcomes and could therefore be combined in multiparametric biomarker models for clinical decision support. However, studies have shown that both the feature definitions and image preprocessing methods significantly impact the performance of the extracted data, emphasizing need for standardization. Furthermore, many studies use in-house developed software, which is often not shared with the public, making reproduction and comparison of the results difficult. To address these issues, we've developed PyRadiomics, with the aim to develop an easy-to-read and easy-to-use toolbox for feature extraction from image to output. It is implemented in Python, which has established itself as a popular language in scientific computing and can be installed on Linux, Windows, and Mac OS X. PyRadiomics provides a pipeline to extract radiomic features from medical imaging data. PyRadiomics contains features for first-order statistics as well as descriptors of the texture and shape of the region of interest. These features can either be extracted from the image directly or from images derived from the original image using a choice of available filters. Extensive documentation on the available features and filters is available online. Once all features are extracted, results are combined and returned to the user for further analysis. To make PyRadiomics easy to use, it follows a modular design centered around the feature extraction module. This module holds the various parameters for a customized extraction and handles interaction with the other parts of the toolbox. Aside from the features and filters, the PyRadiomics toolbox contains a module for image preprocessing and the general info module, which provides additional information about the extraction, such as toolbox version and applied settings. Detailed installation instructions are available at the address shown here. To install PyRadiomics, first download the source code from GitHub. Then, from the root folder of PyRadiomics, run the following two commands in a command line window. The first command, python-m pip install-r requirements.txt, installs all the third-party packages needed to run PyRadiomics. The second line, python setup.py install, installs the actual package and makes PyRadiomics available throughout your system. For the examples of the usage of PyRadiomics, we will be using data contained in the folder structure as shown here. The first folder, data, contains the images and segmentations we will need for the extraction. This second folder, notebook, contains the actual interactive Python example we will be showing later. Thirdly, it contains a file called params. This is a file which holds the customized extraction settings we can use for feature extraction. It contains three parts. The first part, setting, defines the parameters we can use to customize the preprocessing and feature extraction. The second part, input image, defines the filters we want to apply. In this case, only the original filter is defined, meaning features will be only extracted from the original image. Finally, there is feature class, which defines which features should be extracted from the images. In this case, all 5 feature classes are defined, meaning all features will be extracted. This example shows how the PyRadiomics toolbox can be used in a Python interpreter or as part of a Python script. First, import the feature extractor module, which is the only module you will need for the interaction with the PyRadiomics toolbox. Next, store the location of the image and segmentation where you want to extract features from. In this case, we will be using the Brain1 test case. Additionally, store the location of the parameter file we want to customize our extraction with. The following step is to instantiate the extractor, which can be done in 3 ways. The first way is to use the default settings contained within the toolbox. Please note that only the original filter and all feature classes are enabled by default. The second method uses hard-coded settings, meaning the parameters are defined within the Python script. They are stored within a dictionary, which is passed to the feature extractor at initialization. Please note the 2 asterisks, meaning the dictionary will be unpacked as keyword arguments at the function call. The third method is done by passing the location of the parameter file, which will be loaded and used to set the various parameters. Finally, we need to extract features, which can be done by a simple call to the execute function while passing the location of the image and the corresponding segmentation. As shown here, the PyRadiomics toolbox can also provide additional progress information on the extraction. The last part is to show the results. This result consists of the general information containing information on the extraction to enhance reproducibility. The rest of the returned results are the calculated features. Every feature name is defined by the filter, feature class, and the feature name, followed by its value. This example shows how to use the PyRadiomics toolbox from the command line. There are 2 scripts available. The first script is called PyRadiomics and is used for single image processing. To display a help message specifying the various possible commands, use the -h argument. To extract features, specify the image and the segmentation and press enter. The features are now being extracted. This may take some time. By default, the result is returned to the command line window. As you can see, this result is similar to the result shown in the previous example. To customize the extraction, specify the parameters file in the -p argument. Finally, the results can be stored in a separate file for further analysis as shown here. Additionally, a different format can be supplied in the -f argument. In this case, we have chosen to use a CSV or comma-separated values format, which enables easy import of the results into statistical packages for further analysis. The second script, PyRadiomics batch, is very similar in use as the first script. The main difference is that instead of specifying each image and segmentation separately, input is provided as a CSV file specifying each combination of an image and segmentation. Each row represents one such combination and contains 5 elements as shown here. Please note that element 4 and 5 contain the location of the image and the segmentation on the disk. Finally, an output file for the results is required in PyRadiomics batch, whereas it is optional in the first PyRadiomics script. This concludes the video on the development and usage of PyRadiomics. For more information, please visit our website at radiomics.io. Here you can find links to the source code and documentation, as well as links to the radiomics extension for 3D Slicer, which enables the usage of this toolbox directly from the Slicer environment. Finally, we want to encourage a PyRadiomics community for the further development of this toolbox. We'd welcome any questions, suggestions, or comments, which can be posted on the GitHub page or by sending an email to info@radiomics.io.